Hello children, welcome to Chem is Try. We are learning about Haber's process today, which is used for manufacturing ammonia gas. So manufacturing means you are making it in a large quantity. Sir, large quantity means how much? Like say tons together, thousands of kgs. If you do it in a milligrams or grams, that will be preparation. Okay. Haber's process is for manufacturing ammonia. So what are the reactants we are using here? We are using easily available reactants we have to choose. Okay, the reactants should be cheap and easily available because you are preparing it in a large quantity. You should not search for the reactants here and there, right? So the intelligent way is to find cheap and easily available things. So that is one, nitrogen gas. And nitrogen gas is available in what? In air. Plenty of nitrogen available in air. So you will obtain nitrogen gas by fractional distillation of air. Fractional distillation means you will cool the air, okay, turn it into liquid, then do the fractional distillation. At a particular temperature, that is where the boiling point of nitrogen is there, you will get the nitrogen. Then another reactant is hydrogen gas. Sir, hydrogen is not plain easily available in the air. Yeah, but in the last year you learned one thing, that through the Bosch process we can obtain hydrogen, right? So Bosch process, do you remember? We use only water, that is in the form of steam, and we use the coke, which are easily available. So you will get what? Carbon monoxide plus hydrogen. You used to call this as water gas mixture, right? So then when you pass excess of steam, you will get hydrogen gas, and the byproduct will be CO2. So there you have some impurities also, CO2 and CO, which will be removed in that process. But remember here, when you are using both nitrogen gas and hydrogen gas, it should be very pure and should be dried, free from the moisture. And you are using it in the ratio 1:3. 1 volume of nitrogen requires 3 volume of hydrogen. How do you know this? By the balanced equation, N2 plus 3H2 gives you 2NH3 from there. Okay, so we'll see what if it has impurities. We'll see that. Next, what are the favorable conditions? Favorable conditions means which conditions are feasible for this particular reaction. See, if you want to cook the rice, you have to boil the water. Means only at that particular condition, and that too if you do it in the pressure cooker, so then there is a pressure also. Only in that condition it will cook the rice. So then for this particular reaction, what do you need? You need, okay, let me remove this, temperature, which is optimum temperature of around 450 to 500 degrees Celsius. We use pressure about 200 atm. See, the pressure range is from 200 to 900 atm, so you can choose any pressure between these two. Usually the ideal pressure we take is 250 atmosphere. Then what do you need? We need a catalyst, that too finely divided iron catalyst. Sir, what happens if I take iron rod and put it? Then there is no reaction or very less reaction. Then why we need to make it finely divided means powder form? See, these particular reactions where you are using the gases, they need some surface. So say this is the surface of the catalyst. What happens? The nitrogen reactant and hydrogen both will come and sit on the surface of the catalyst. Okay, then they will interact with each other, and then they will break the existing bonds and form the new bonds. This is the procedure. So to get the larger surface area, To get the larger surface area, more the surface area, more will be the reaction. We make the fine powder of the catalyst. Okay, understood? Then last one is promoter. We are using here molybdenum as the promoter. Molybdenum, or you can also use aluminium oxide. Again, these also will be in the powder form, but you are not using it in large quantity, only trace amounts you are using. So sir, what is the role of the promoter? It enhances the activity of the catalyst. What is the role? It enhances the efficiency, means it will make the catalyst more efficient. Efficiency of the catalyst. Wherever you use any promoter, its role is that only. Enhance the efficiency of the catalyst. Fine. So these are the favorable conditions. 450 to 500 degrees Celsius, above 200 atmosphere, catalyst is finely divided iron, promoter is the traces of molybdenum or aluminium oxide. So some important points before we proceed further. So the rate of conversion in this reaction is only 15%. The meaning of this is, if you take nitrogen, what are the reactants? Nitrogen and hydrogen in the ratio 1:3, you will get the ammonia. If you take 100 gram of the reactants, only 15 gram of it will react and give you the products ammonia. And remaining 85 gram will be what? Remains unreacted. So this is called as rate of conversion, 15% conversion. So then what we will do? How do you proceed it further if only 15% is converted, right? So we have a technique. You have to remove, because it is a reversible reaction. If there is ammonia, it will keep on converting back into reactants. So your yield will be less. So the recovery of ammonia we do for that purpose. One thing, you liquefy it, means you just convert it into liquid. So its condensation point is -33 degrees Celsius, which will be very less compared to nitrogen and hydrogen, means ammonia will liquefy easily. Or you can simply absorb it in water, because ammonia is highly soluble in water. Remember the fountain experiment. Okay, so if you remove both of these, you will get the better yield. So we continue this reaction until we get the 98% of the yield. Okay, then what is the process? So the process is very simple. You have only three chambers, you can call it. First one is compression pump or compression chamber. Second one is catalytic chamber. Third one is condenser. Let's see what is each and everything. So first you will take the reactants. Dry nitrogen 1 volume, dry hydrogen 3 volumes in the ratio 1:3. You already took that, and you will send it to the compression pump, where you are compressing the gases. Sir, why we have to compress it? Why you have to put pressure on them? Poor people, right? See, nitrogen and hydrogen both are gases. So one nitrogen is here, hydrogen will be here. Then how do they react? Right? So first you will make them come closer. So to make them to come closer, you will apply pressure. So how they will come closer if I apply pressure? Check. Pressure. Pressure is inversely proportional to volume. So if you increase the pressure, what happens to volume? Volume decreases. Means they will come closer and closer. Simple. What is this? At constant temperature, this is Boyle's law. So you are keeping the pressure 200 to 900, but practically around 250 atm. So compression chamber is this much only. Then whatever N2 and H2 compressed, they will be sent to the next chamber, that is catalytic chamber. Why you call it as catalytic chamber? Because you are using the catalyst here. So this is the main where the reaction is actually taking place. So you use here electrically heated catalytic chamber. Catalyst will be finely divided iron. Promoter is molybdenum or Al2O3 traces. Temperature is 450 to 500. Pressure is above 200 atmosphere. So with these ideal conditions, when you do the reaction, so you will get this catalytic reaction. N2 plus 3H2. Reversible reaction arrow you have to write. Remember, on the top you are writing iron, catalyst and molybdenum, or you can also write instead of this Al2O3. Temperature you are writing below 450 to 500. Pressure we are keeping above 200 atmosphere. So you are getting the ammonia plus heat. So when they ask you to write catalytic reaction, you have to write whole of this. Heat also you have to write. This is an exothermic reaction. Okay. So whatever heat release, that itself will carry out the further reaction. So you will heat the reactants only initially, then whatever heat released in the reaction, that itself will carry out the reaction. A point to be noted, iron is finely divided and molybdenum is in trace quantity. Okay, so this is the catalytic reaction. Last chamber is condenser chamber or cooling chamber also you can call, where what and all coming from the catalytic chamber, ammonia is there, okay, plus unreacted nitrogen and hydrogen. Remember, only 15% conversion means 85% are remaining nitrogen and hydrogen. All three are coming. So when all three come here, you will cool. You will have the temperature here, say around minus 33 degrees Celsius. Only ammonia will liquefy. You will take it out, liquid ammonia. So then, what about nitrogen and hydrogen? Nitrogen and hydrogen are unreacted one will be sent back to the first chamber, that is the compression chamber, because you removed the liquid ammonia. N2H2 you will send back to compression chamber, so the same cycle will repeat here. Okay, they will again come to catalytic chamber, 15% conversion, condenser chamber, convert it into liquid ammonia, again send it. You will repeat this till what? Till you get 98% yield. Okay, last point, some important points. First one, nitrogen and hydrogen must be dried and pure. What is the reason? This is very important question. Nitrogen and hydrogen may contain impurities like CO, CO2, H2S. Where it came from? CO, CO2 may came from Bosch process. Okay, from where you get hydrogen. H2S may be present in the air in trace quantity. Where you will get it? From the nitrogen. So these people will poison the catalyst. So the catalyst is there. These people will come and sit on the surface of the catalyst. So it will block the activity of the catalyst. So you call it as poisoning the catalyst. Means the reaction will stop. Okay. So therefore, it is very, very important to remove these people. Next, what is the role of a promoter? You will use molybdenum or Al2O3. What is the role? We already discussed about this. It is to enhance the efficiency of the catalyst. Last one, why is heating provided initially only but stopped after the reaction started? So initially what happens, because the reaction is exothermic, it itself will carry out the reaction, but initially you need to just heat it to initiate the reaction. Okay. To finally, to summarize the reaction, you will have nitrogen and hydrogen in the ratio 1:3 pure and dried. You will send it to compression chamber where you are keeping about 200 atmosphere pressure. Then you will send it to the catalytic chamber where you are doing the reaction, catalytic reaction by keeping those conditions, and then finally you will send it to condenser chamber where you remove the liquid ammonia. The unreacted nitrogen and hydrogen will be sent back to the first chamber. And what is the catalytic reaction here? N2 plus 3H2, reversible reaction, 2NH3 plus heat. The 15% conversion only happens in each cycle, then overall you will get 98% yield. Okay, so that's about the Haber's process. Hope you understood this. If any doubt, please comment. Thank you so much for your time.